to our channel, children. Today we are going to discuss hybridization of coordination complexes with coordination number 4. Like how I have discussed in my previous video, you have to remember two important points: strength of ligands and how to calculate the oxidation state of central metal ion. Here, CO is strong ligand, Cn minus is also a strong ligand, NS3 strong or weak depending on the nature of the central metal ion, H2O is a weak ligand and X minus is also a weak ligand. I am taking only few ligands into consideration. If you study the spectrochemical series in CBSE textbook, you will be getting an idea of the strength of all the ligands. The second step is to calculate the oxidation state of central metal ion. Now let us directly come to the complex. The first step to calculate the oxidation state of central metal ion. Cl, the charge is -1. You have 4 Cl minus, so -4 is equal to, outside the coordination entity, you have -2. So what will be the oxidation state of nickel? +2, because +2 minus 4 only will give you -2. So from the electronic configuration of nickel, argon 3d8 4s2, remove 2 electrons from s orbital. So we have argon 3d8 4s0. Now let us arrange these 8 electrons in the 3d orbital. Cl is a weak ligand, hence no pairing will take place. And the complex will be outer orbital complex because it is the outer orbital that is taking part in hybridization. You have 4 ligands, so you have 1 4s and 3 4p orbitals taking place in hybridization, because 4 ligands you need 4 boxes, 1 2 3 4. These atomic orbitals will intermix to give you 4 sp3 hybrid orbitals having same energy and same shape. Now into this sp3 hybrid orbitals, Cl minus ligand will donate 4 pair of electrons forming 4 coordinate covalent bonds giving a tetrahedral shape. Now you can see there are 2 unpaired electrons. So N is equal to 2 and the complex is paramagnetic. What is the magnetic moment? Nu is equal to, use the formula root of n into n plus 2. Here n is 2. So you have root of 2 into 2 plus 2, root of 8, root of 9 is 3, sorry, root of 8 approximately 2.8 bm. The complex is paramagnetic with a magnetic moment of 2.8 bm. Here, this is an outer orbital complex because Cl is a weak ligand. No pairing is taking place. Now let us go to the next complex. Tetracynoplatinate 2. Here, first step is to find the oxidation state of central metal ion. Cn has a charge of -1, 4 Cn, so -4 is equal to, outside the coordination entity you have -2. So here platinum should have an oxidation state of +2. Now here you have the electronic configuration of platinum. Remove 1 electron from S and 1 electron from D. So you have the electronic configuration xenon 4f14 5d8. Now arrange these 8 electrons in the atomic orbitals. Now you can see Cn is a strong ligand. When Cn is a strong ligand, the pairing of these 2 electrons will take place. After pairing, you have 1 5d empty orbital. So hybridization will start from this 1 5d empty orbital. There are 4 ligands, 4 hybrid orbitals you need. So 1 5d, 1 4s and 2 6p orbitals will intermix to form dsp2 hybridization or dsp2 hybrid orbitals. You have 4 dsp2 hybrid orbitals. Into this hybrid orbitals, Cn minus ligand will donate 4 pair of electrons forming 4 coordinate covalent bonds giving a square planar shape. When the hybridization is dsp2, the shape is square planar. When the hybridization is sp3, shape is tetrahedral. Now you can see here no unpaired electrons are there. So magnetic moment nu is 0 because n is 0 and the complex is diamagnetic. Now let us go to the next complex. Tetraamine nickel 2. Here the charge of ammonia is 0. Outside the coordination entity plus 2. So nickel will have a charge of plus 2. Now remove 2 electrons from nickel. Let us remove 2 electrons from s orbital. So you have Ni2 plus as the electronic configuration argon 3d8. Now let me arrange the 8 electrons in this 3d orbital. Now in the case of nickel, NH3 is a weak ligand. Because NH3 is a weak ligand, no pairing will take place. When no pairing takes place, the hybridization will start from the 4s orbital. See, 1 4s and 3 4p orbitals will intermix to give 4 sp3 hybrid orbitals, giving a tetrahedral shape. And into this 4 sp3 hybrid orbitals, NH3 ligand will donate 4 pair of electrons to form 4 covalent bond, giving a tetrahedral shape. The shape is tetrahedral because the hybridization is sp3. Now you can see there are 2 unpaired electrons. When there are 2 unpaired electrons, n is equal to 2 and the complex is paramagnetic. Magnetic moment nu is equal to root of n into n plus 2. The value of n is 2. So you have 2 into 2 plus 2, root of 8. Root of 8 will be approximately 2.8 bm. Bm is the unit of magnetic moment, Bohr magneton. So in this complex, the shape is tetrahedral because hybridization is sp3 and the complex is paramagnetic. Now let us go to the next complex, NiCO4, tetracarbonyl nickel. The first step, CO is a very strong ligand, you know that. Strong. And the charge of CO is 0. Outside the coordination entity, no charge. So charge of Ni is also 0. No plus or minus charge. It is 0. Now we can't remove any electron because the oxidation state of Ni is 0. Now let us arrange these 8 electrons in the d orbital and 2 electrons in the 4s orbital. Now CO being a very strong ligand, the 2 electrons from the 4s orbital will come and pair with the 3d orbitals. And 4s orbital becomes empty. Now you can see hybridization will take place with 1 4s and 3 4p orbitals to give 4 sp3 hybrid orbital, and carbonyl group will donate 4 pair of electrons to form 4 covalent bonds with the central metal ion nickel to give a tetrahedral shape. The shape is tetrahedral because the hybridization is sp3. Now you can see there are no unpaired electrons. So n is 0, magnetic moment nu is 0 and the complex is diamagnetic. Whenever there is unpaired electron, the complex will be colored. When there is no unpaired electron, the complex will be colorless. Here the complex is having no unpaired electron, so this complex will be colorless. This point also you should keep in mind. Now I have included here 2 questions to test your knowledge. If you have any doubt in answering these questions, please let me know in the comment box. Hope you like this. Please like, comment and subscribe the channel. Thank you.